Hello, this is Nat with the Welcome Pets again. Today we're going to be attempting question 2 of MAT 2017. So there is a unique real number alpha that satisfies this equation. Okay, sorry, wrong function. Let's try again. Much better. So show that 0 alpha to 1. So we move the 1 to the other side and let's define the function f alpha, which does exactly that. Alpha cubed plus alpha squared minus 1. So f0 equals to minus 1 and f1 equals to 1. And guess what this means? By the sign change rule, there is a root between 0 and 1, and that root is alpha. So let's show that alpha for expression. So let's write down the defining equation. Alpha cubed plus alpha squared equals to 1. To get an alpha 4, we shall multiply everything by alpha. So alpha 4 equals to alpha minus alpha cubed. By using the defining equation again, we get alpha 4 is alpha minus 1 minus alpha squared. So let's write down our identities down. Alpha cubed equals to 1 minus alpha squared. Got that. So that means alpha 4 equals to minus 1 plus alpha squared. Done. We put the identity. Let's write it down. Done. So let's find the quadratic expression now of alpha. First, the inverse of alpha, aka alpha minus 1 or the reciprocal of alpha. What do? We use a defining equation. Again, we always use definitions. Sorry. And then we divide everything by alpha. Great, so here's our quadratic expression. Let's just write down the coefficients to make it clear. And the infinite sum. It's a geometric series with common ratio, everything a alpha, and a equals to 1. So that means it's 1 over 1 plus alpha. What do? So this alpha cubed plus alpha squared has a factor of alpha squared 1 plus alpha. There. So what we're going to do is that we're going to whittle this whole thing out. It's equals to alpha squared over alpha squared 1 plus alpha, and alpha cubed plus alpha squared is 1, so it's alpha squared. Yay! What's the next one? 1 minus alpha to the power of negative 1. Now, when you look at the geometric series another way, it's first term 1 minus alpha and common ratio alpha squared. Oops, we fall into a dead end again. So what we're gonna do is that we're gonna possibly write 1 over 1 minus alpha. As we can see from our identities here, we can't do it. What do? We use the difference of cubes identity. So alpha cubed equals to alpha squared plus 1. Alpha squared equals 1. And as you can see, we always use definitions. Alpha squared equals to 1 minus alpha cubed. And using the differences of cubes identity, you get alpha squared equals to 1 minus alpha, 1 plus alpha squared. So we're going to whittle the terms out, equals to 1 plus alpha squared. And then we're going to put the alpha squared at the bottom, equals to 1 plus 1 over alpha plus 1 over alpha squared. Back to this, we're going to scroll right and up. Now, how do we expand 1 plus 1 over alpha plus 1 over alpha squared? As we can see, alpha minus 1, let's scroll again. It's alpha cubed plus alpha squared. Wait, it's alpha squared plus alpha. So we're gonna write 1 plus alpha squared plus alpha squared plus alpha squared. I was gonna say alpha, but here we go, and we're gonna expand this binomial. As you know the binomial theorem, you will have alpha 4 plus 2 alpha cubed plus alpha squared. See our identities list here? It's gonna be really helpful when we move on. Equals to 1 plus alpha squared plus alpha minus 1 plus alpha squared plus 2 minus 2 alpha squared plus alpha squared. Moving on, we will whittle out the x alpha squared terms. Oh, sorry, we'll move on. Sorry, this journey is a lot rockier than we expected. Continuing on, we will have, look at this, where constant terms are 2, and then we have 2 alpha plus alpha squared. Okay, now what's the last question? The last question we have is this. 1 plus alpha, 1 plus alpha squared, 1 plus alpha 4, 1 plus alpha 8. So let's write this down. 1 plus alpha, let's call it P for product. Now what are we gonna do? We are going to multiply the whole thing by 1 minus alpha equals to 1 minus alpha, 1 plus alpha, 1 plus alpha squared, 1 plus alpha 4, dot, 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 dot. As you can see, this creates a cascading effect. So this is 1 minus alpha squared, 1 plus alpha squared, and then this will become 1 minus alpha 4, and so on, until P 1 minus alpha equals to 1 minus alpha squared infinity. Since alpha is between 0 and 1, we can use this factorial advantage by cancelling off this term. So that means our big infinite product has turned into a small but important 1 over 1 minus alpha. And continuing on, we can use our expression equals to 2 plus 2 alpha plus alpha squared. So there you go. The whole question 2 of 2017. I really hope you like it, and subscribe and like for more videos.